Hi, my name is Li Xinyue, and my student ID is 3 666 6025. So this video, I will explain how I implemented the code system and the plasma cutter features for requirement one, and also the design decisions behind them. First, for the code system, I created a separate code manager class. Each supercomputer owns its own code manager, which manages company credits, code targets, deadlines, and company rank progression. For example, if there are multiple supercomputers on the map, each one tracks its own quota progress independently instead of sharing a global quota state. To handle quota failures, I introduced the quota failure listener interface. When a quota deadline is missed, the quota manager broadcasts a quota failure event to all registered listener. The manager only knows that it should notify a listener, but it doesn't know how individual objects respond. This keeps the code logic separate from actor behavior and reduce coupling. Next, I implemented the deposit system using a depositable interface and deposit action. Deposit action handles the common workflow such as adding company credits and removing the deposited item. The item itself defines any special effects. For example, depositing an alien artifact can teleport the worker, while depositing an industrial fund heals the workers. This keeps the deposit process reusable while allowing different resources to behave differently. Now I will talk about the cutter feature. The plasma cutter itself is quite simple. It only provides the cut ability through the game item ability enumeration. This means the system doesn't need to check for a specific item type such as this cutter. Instead, it only checks whether the actor has an item with a cut ability. This follows the capability-based design style used throughout this subject. For cutting interactions, I created a cuttable interface and a reusable cut action. Different objects such as the door, vent, and alien cube implement cuttable interface and define their own cutting effects. For example, when a worker carrying a cutter interacts with an aluminum door, cut action utilities first check the worker's inventory for an item with the cut ability. If found, it creates a cut action. When the action is executed, it calls the door's onCat method. The door then transforms into a floor, drops a aluminum crab, and may explode with a 25% chance. The same cut action can also work for a vent or an alien cube because the action only depends on the cuttable interface rather than specific object types. This means I can add new cuttable objects later without modifying cut action itself. I also introduced the cut action utilities to centralize the repeated inventory checking logic. Without this utility class, every cuttable object would need to duplicate the same code for checking whether the actor carries a cutter. Overall, my implementation focused on separating responsibility, reducing couplings, and improving extensibility through interfaces, capabilities, and strategy-based design. That's all. Thank you.